The way we travel is on the cusp of a revolution. A new era of transportation is dawning, one that promises to change the way we think about distance and time. Imagine a world where distance is no longer a barrier, where the vast expanses that once separated us are bridged in the blink of an eye, where journeys that once took hours can be completed in minutes, transforming the way we live, work, and connect with each other. This is the promise of the Hyperloop, a groundbreaking transportation system poised to redefine the future of travel. Imagine traveling at speeds that rival those of airplanes, but with the convenience of a train. The Hyperloop concept, popularized by Elon Musk, envisions a network of sealed tubes where pods travel at incredible speeds, propelled by magnetic levitation and electric propulsion. This innovative approach minimizes friction and maximizes efficiency. The Hyperloop's potential impact on travel is immense. It promises not just faster travel, but a complete overhaul of our transportation infrastructure. By offering significantly reduced travel times, it has the power to reshape our cities, economies, and daily lives. Imagine the possibilities of living in one city and working in another, without the stress of long commutes. Imagine commuting between major cities in the blink of an eye, opening up new possibilities for work, leisure, and connecting with loved ones. The Hyperloop could make weekend getaways to distant cities a regular occurrence. The Hyperloop offers a glimpse into a future where geographical boundaries are less of an obstacle and travel becomes seamless and efficient. It's a vision of a world where the constraints of distance are diminished. This revolutionary technology has the potential to alleviate traffic congestion, reduce carbon emissions, and create a more sustainable future for our planet, and connect people and businesses in unprecedented ways. The Hyperloop could foster new economic opportunities and collaborations across regions. As we explore the possibilities of the Hyperloop, we enter a new era of travel, one characterized by speed, efficiency, and transformative possibilities. It's not just about getting from point A to point B, it's about revolutionizing the journey itself. The Hyperloop is not merely a mode of transportation, it represents a paradigm shift in how we perceive distance and connectivity. It's a bold step towards a future where the world feels smaller, more connected, and more accessible than ever before. At its core, the Hyperloop system is elegantly simple, relying on a high-speed, low-pressure environment to achieve unprecedented speeds. Imagine a sealed tube or track with near-vacuum conditions minimizing air resistance. Within this tube, pods carrying passengers or cargo glide effortlessly on a cushion of air, propelled by magnetic levitation. This magnetic levitation, similar to the technology used in some high-speed trains, eliminates friction, allowing the pods to reach astonishing speeds. Electric propulsion systems, powered by renewable energy sources, further enhance the Hyperloop's efficiency and sustainability. The pods, designed for aerodynamic efficiency, minimize drag, contributing to the system's impressive speed capabilities. To ensure a smooth and comfortable ride, the Hyperloop incorporates advanced control systems that regulate speed and maintain stability. These systems constantly monitor and adjust the pod's position within the tube, ensuring a safe and enjoyable travel experience. The near-vacuum environment inside the tube not only reduces air resistance but also minimizes noise pollution, creating a remarkably quiet and serene journey for passengers. The Hyperloop, once a futuristic concept, is rapidly moving from science fiction to reality, with numerous companies and research institutions around the world actively developing and testing this groundbreaking technology. One of the leading companies in the Hyperloop race is Virgin Hyperloop, which has made significant strides in testing and development at its test track in Nevada, USA. In 2020, Virgin Hyperloop conducted a successful passenger test, marking a major milestone in proving the viability of this revolutionary transportation system. Other companies, such as Hyperloop Transportation Technologies, HTT, and Transpod, are also making notable progress, with plans to build Hyperloop systems in various parts of the world. These projects are not limited to one particular region. They span continents, highlighting the global interest and investment in Hyperloop technology. From the deserts of the United Arab Emirates to the bustling cities of Europe and Asia, Hyperloop projects are underway, promising to connect people and places in unprecedented ways. As research and development continue, we can expect to see further advancements in Hyperloop technology, bringing us closer to a future where high-speed, sustainable travel becomes the norm. Section 4. Building the future. 3D printing and sustainable infrastructure. While the Hyperloop represents a paradigm shift in transportation, other groundbreaking innovations are transforming the very fabric of our built environment. These advancements are not just limited to how we move, but also to how we build and sustain our cities and communities. One such innovation is 3D printing, a technology that is revolutionizing construction and infrastructure development. This method, also known as additive manufacturing, involves creating structures layer by layer, which allows for unprecedented precision and customization. Imagine a future where bridges, buildings, and even entire houses can be printed on demand layer by layer using advanced robotic systems and sustainable materials. This vision is not far from reality as 3D printing technology continues to evolve and improve. This is the promise of 3D printing in construction, a technology that offers numerous advantages over traditional building methods. It can significantly reduce construction time and costs, making it an attractive option for both large-scale projects and smaller, more personalized builds. 3D printing allows for greater design freedom, enabling architects and engineers to create complex and innovative structures that were previously impossible to build. This opens up new possibilities for architectural creativity and functional design. It also reduces material waste, as only the required amount of material is used in the printing process. This efficiency not only lowers costs, but also minimizes the environmental impact of construction activities. Furthermore, 3D printing can significantly accelerate construction timelines, as the automated process can operate 24/7, regardless of weather conditions. This capability is particularly beneficial in regions with harsh climates or during times when rapid construction is essential. This technology has the potential to revolutionize disaster relief efforts, allowing for the rapid construction of shelters and other essential infrastructure in the aftermath of natural disasters. Quick deployment of these structures can save lives and provide much-needed stability in crisis situations. As 3D printing technology continues to advance, we can expect to see even more innovative applications in construction, paving the way for a future where sustainable, efficient, and resilient infrastructure becomes the standard. This evolution will not only enhance the quality of our built environment, but also contribute to a more sustainable and resource-efficient world. Section 5. Smart materials, smarter infrastructure. Adapting to the future. The future of infrastructure is not just about building new structures. It's also about making our existing infrastructure smarter and more adaptable. This means integrating advanced technologies and materials into the very fabric of our cities and communities. This is where smart materials come in, materials engineered with remarkable properties that allow them to respond to changes in their environment. These materials can sense, react, and adapt to their surroundings, making them invaluable in modern construction. Imagine concrete that can heal its own cracks, reducing maintenance costs and extending the lifespan of our roads and bridges. This self-healing capability is achieved through the incorporation of microcapsules filled with a healing agent that is released when cracks form. This is now a reality with the development of self-healing concrete, a material embedded with microcapsules that release a healing agent when cracks appear, effectively repairing the damage. This innovation not only saves money but also significantly reduces the environmental impact of constant repairs. Similarly, shape memory alloys, another type of smart material, can revert to their original shape after being deformed, offering potential applications in earthquake-resistant buildings and self-adjusting bridges. These alloys can absorb and dissipate energy, providing an extra layer of safety during seismic events. These smart materials are not limited to concrete and alloys. Researchers are exploring a wide range of materials with unique properties that can be harnessed for infrastructure applications. From polymers that change color to indicate structural stress to materials that can self-clean, the possibilities are endless. For instance, piezoelectric materials generate electricity when subjected to pressure, offering a potential solution for powering streetlights or sensors by harnessing the energy from footsteps or passing vehicles. This could lead to more sustainable and energy-efficient urban environments. As our understanding of material science grows, we can expect to see even more innovative smart materials emerge, further enhancing the functionality, sustainability, and resilience of our infrastructure. These advancements will not only improve the quality of life for people around the world, but also help us build a more sustainable and resilient future.